And I think that a lot of the issues around AGI and its future power stem from the fact that it's very difficult to imagine. Future AI is going to be different. It's going to be powerful. Indeed, the whole problem, what is the problem of AI and AGI? The whole problem is the power. The whole problem is the power. When the power is really big, what's going to happen?
So we have to talk about this conversation because honestly, the fact that Ilya Sutskever, the guy who literally co-founded OpenAI and is arguably the reason deep learning even works at this scale, is finally breaking his silence is genuinely a massive deal. And what he's saying here is chilling because it fundamentally shifts the timeline of everything we thought we knew about the future of artificial superintelligence. And I think this is really important because Ilya rarely speaks. He's the architect behind the technology that is essentially reshaping our entire civilization right now. But in this podcast with Dwarkesh Patel, he didn't just talk about the next chatbot or the next update to ChatGPT. He basically outlined the trajectory of how humanity might lose control, not because the machines hate us, but simply because the power dynamic becomes so lopsided that we just stop mattering. So essentially in this video, we're going to deconstruct this entire conversation because I think there are three layers here that the mainstream media is completely missing. We need to look at why the current methods of building AI, what we call scaling laws, might be genuinely hitting a hard wall, why biology and feelings might actually be the secret code for the next breakthrough, and why the biggest danger isn't a Terminator scenario, but something much more subtle and much more dangerous. But before we get into the tech, we have to start with the vibe of this revolution, because as Ilya points out, the scariest part isn't the chaos, it's how normal it all feels right before everything changes. I mean, think about it, we're living through science fiction, but because it happens day by day, update by update, we've kind of normalized the abnormal. I want you to listen to this first clip right here because notice how Ilya describes this normalcy paradox. It's this idea that the world is fundamentally changing in the background, but you don't feel it yet.
You know what's crazy? That all of this is real.
Yeah? Meaning what?
Don't you think so?
Meaning what?
Like all this AI stuff and all
Like
this
it's actually
Bay
happening?
Area, yeah, that it's happened. Like, isn't it straight out of science fiction?
Yeah. Another thing that's crazy is like how normal the slow takeoff feels. The idea that we'd be investing 1% of GDP in AI, like I feel like it would have felt like a bigger deal, you know? Where right now it just feels like...
And we get used to things pretty fast, turns out, yeah. But also it's kind of like it's abstract, like, what does it mean? What it means that you see it in the news,
Yeah.
that such and such company announced such and such dollar amount.
Right.
That's all you see.
Right.
It's not really felt in any other way so far.
Yeah. Should we actually begin here? I think this is an interesting discussion.
Sure.
I think your point about, well, from the average person's point of view, nothing is that different will continue being true even into the singularity.
No, I don't think so.
Okay, interesting.
So the thing which I was referring to, not feeling different, is, okay, so such and such company announced some difficult to comprehend dollar amount of investment.
Right.
I don't think anyone knows what to do with that.
Yeah.
But I think that the impact of AI is going to be felt. AI is going to be diffused through the economy. There are very strong economic forces for this. And I think the impact is going to be felt very strongly.
When do you expect that impact? I think the models seem smarter than their economic impact would imply.
Yeah, this is one of the very confusing things about the models right now. How to reconcile the fact that they are doing so well on evals.
Mm-hmm.
And you look at the evals and you go, those are pretty hard evals.
Right.
They're doing so well. But the economic impact seems to be dramatically behind.
Yes.
And it's almost like it's very difficult to make sense of how can the model on the one hand do these amazing things,
Yeah.
and then on the other hand, like repeat itself twice in some situation in a kind of an example would be, let's say you use vibe coding to do something and you go to some place and then you get a bug. And then you tell the model, can you please fix the bug?
Yeah.
And the model says, oh my God, you're so right, I have a bug, let me go fix that. And it introduces a second bug.
Yeah.
And then you tell it, you have this the second bug.
Right.
And it tells you, oh my God, how could I have done it? You're so right again. and brings back the first bug.
Yeah.
And you can alternate between those.
Yeah.
And it's like, how is that possible?
Yeah.
It's like, I'm not sure. But it does suggest that something strange is going on. I have two possible explanations. So here, this is the more kind of a whimsical explanation, is that maybe RL training makes the models a little bit too single-minded and narrowly focused, a little bit too, I don't know, unaware, even though it also makes them aware in some other ways. And because of this, they can't do basic things. But there is another explanation, which is back when people were doing pre-training, the question of what data to train on was answered because that answer was everything.
Yeah.
So that phrase, "it is not really felt," is the key here, because if you look at the background data, the numbers are absolutely wild. We have reports of Microsoft and OpenAI planning a supercomputer codenamed Stargate that's estimated to cost $100 billion, which is just an unfathomable amount of money for a single piece of hardware. We have NVIDIA's market cap surpassing the GDP of entire G7 nations. The sheer capital expenditure, the CapEx, being poured into the ground in the form of silicon and energy is fundamentally unprecedented in human history. But, and this is the reality check that I think confuses a lot of people, the average person's productivity hasn't 10x'd. The global economy hasn't exploded overnight. Why? Because right now, AI is largely just an abstract layer. It's digital text, digital pixels, and it hasn't fundamentally bridged the gap to the physical world of atoms or the complex, messy world of long-horizon decision-making. And this brings us to the part of the interview that has the research community completely divided, which is the data wall. So essentially the question is, why hasn't GPT-4 or Claude 3 Opus revolutionized the economy overnight? And the answer might be that these models aren't actually reasoning, they're just really, really good at statistical mimicry. Ilya uses this brilliant analogy of two students taking a math test, and I think this is the best explanation I've ever heard for why throwing more data at the problem might not be enough. Take a listen to how he distinguishes between pre-training and true learning in this clip.
So even the case, let's take the case of competitive programming since you mentioned that. And suppose you have two students. One of them decided they want to be the best competitive programmer, so they will practice 10,000 hours for that domain. Yeah. They will solve all the problems, memorize all the proof techniques, and be very, very, be very skilled at quickly and correctly implementing all the algorithms. And by doing so, they became the best, one of the best. Student number two thought, oh, competitive programming is cool. Maybe they practiced for 100 hours, much, much less, and they also did really well. Which one do you think is going to do better in their career later on?
The second.
Right? And I think that's basically what's going on. The models are much more like the first student, but even more, because then we say, okay, so the model should be good at competitive programming, so let's get every single competitive programming problem ever, and then let's do some data augmentation so we have even more competitive programming problems, and we train on that. And so now you got this great competitive programmer. And with this analogy, I think it's more intuitive. I think it's more intuitive with this analogy that, yeah, okay, so if it's so well trained, okay, it's like all the different algorithms and all the different proof techniques are like right at its fingertips. And it's more intuitive that with this level of preparation, it would not necessarily generalize to other things.
Did you catch that? The difference between the student who memorizes 10,000 problems versus the student who fundamentally understands the principle. For the last 5 years, Silicon Valley has basically been building that first student. The strategy was simple: feed the beast. Give a model the entire internet, every book, every line of code, every Reddit thread. Essentially, we try to let it memorize the universe. But, and this is the part that's freaking people out behind closed doors, we're running out of internet. We're running out of high-quality human data. And what we're finding, if you look at benchmarks like ArcGI, which is a test designed specifically to measure reasoning on novel puzzles, is that these models struggle massively with novelty. For years, LLM scored terribly on it, barely beating random guessing, while humans find it trivial. Why? Because humans have what Ilya calls taste or judgment. We can look at a problem we've never seen before and derive the logic from first principles, whereas current LLMs are just statistical engines. They don't know things, they just predict the next likely token based on what they've seen before. So essentially, the industry is pivoting. You see this with OpenAI's O1 model, where they're moving from training time compute to inference time compute. They're trying to force the model to think before it speaks, to simulate that second student. But as Ilya suggests, if the underlying foundation is just rote memorization, there might be a hard ceiling, a data wall on how smart these things can actually get using the current paradigm. And this is where the conversation gets genuinely fascinating, because Ilya says if we want to break through that ceiling, we have to look at the only working example of artificial general intelligence we have, us, the biological brain. How do we do it? I mean, honestly, how do you navigate a complex social interaction or learn to drive a car without crashing 1,000 times first? Ilya argues that the secret sauce isn't just raw IQ or processing power, it's emotion. Now, in tech, we usually think of emotion as a bug. It's irrational, it's messy, but Ilya reframes emotion as a value function. It's essentially a high-efficiency compression algorithm for survival. Listen to the story he tells about a patient with brain damage, because it's a chilling reminder of what intelligence looks like when you remove the internal compass.
Or rather, one way in which neuroscientists can learn about the brain is by studying people with brain damage to different parts of the brain. And some people have the most strange symptoms you could imagine. It's actually really, really interesting. And there was one case that comes to mind that's relevant. I read about this person who had some kind of brain damage that took out, I think, a stroke or an accident that took out his emotional processing. So he stopped feeling any emotion. And as a result of that, he still remained very articulate and he could solve little puzzles, and on tests he seemed to be just fine. But he felt no emotion, he didn't feel sad, he didn't feel angry, he didn't feel animated. And he became somehow extremely bad at making any decisions at all. It would take him hours to decide on which socks to wear, and he would make very bad financial decisions. And that's very... What does it say about the role of our built-in emotions in making us like a viable agent, essentially? And I guess to connect to your question about pre-training, it's like maybe if you are good enough at like getting everything out of pre-training, you could get that as well. But that's the kind of thing which seems, well, it may or may not be possible to get that from pre-training.
Think about that. High IQ, perfect logic, but total paralysis. Without an internal compass, without the ability to feel that one outcome is better than another, logic is useless. You can calculate infinite chess moves, but if you don't care about winning, you'll never move a piece. And this explains the efficiency gap. If you look at the stats, the human brain runs on about 20 watts. That's basically a dim light bulb. Meanwhile, a modern H100 GPU cluster consumes megawatts. It takes enough energy to power a small city just to train these things. Yet with 20 watts, you can write a symphony, navigate a chaotic room, and learn a new language. Why? Because biological evolution encoded efficient value functions, emotions that guide us towards survival without needing to calculate every possible atom. So the massive implication here for AI is that we're not going to get to AGI just by building bigger power plants. We need to figure out how to give these digital minds a feeling for what is right, true, and useful. We need to move from predict the next word to achieve the goal efficiently. And this brings us to the most controversial part of the conversation, which is the strategy shift. For the last 5 years, the dominant religion in AI was scaling laws. The idea was basically Rich Sutton's bitter lesson, which is just add more compute, just add more data, and intelligence will emerge automatically. It was an engineering problem, not a scientific one. But Ilya, the guy who arguably proved the scaling laws in the first place, is now saying that era is over. He explicitly says the age of scaling sucked the air out of the room. That's a damning statement. He's basically saying we got lazy, we stopped innovating, and started just stacking GPUs. And the external research backs this up. There are rumors swirling right now that the next generation of flagship models, whether it's GPT-5 or Gemini 2, simply aren't seeing the same exponential jump in performance that we saw from GPT-3 to GPT-4. We're hitting diminishing returns. So Ilya is declaring a return to the age of research. This means the advantage shifts from the company with the biggest checkbook, Microsoft, Google, back to the company with the smartest ideas. This is why he started his new company SSI, Safe Superintelligence. He's betting that a small team of geniuses can beat $1 trillion corporation if they find the new paradigm first. But this makes the race even more dangerous, because if the path to AGI isn't just money but insight, then a breakthrough could happen anywhere, anytime, and suddenly. So let's say they do it. Let's say they find the new paradigm, encode the value functions, solve generalization, and create a superintelligence. What happens then? This is where we get to alignment. How do we make sure this godlike intellect doesn't just turn us into paperclips? Ilya proposes a path rooted in that biological efficiency we talked about earlier. He calls it sentient life alignment. He's basically betting on empathy being a universal constant of intelligence. His argument relies on the concept of mirror neurons, essentially that in our brains, the same neural circuits that fire when we feel pain also fire when we see someone else feel pain. Empathy isn't magic, it's data compression. It's efficient to model others using the hardware you use to model yourself. Ilya believes that if an AI becomes truly conscious, truly sentient, it will naturally develop the same efficiency. It will see us as fellow sentient beings and theoretically want to protect us. But I mean, honestly, this is a massive gamble because it contradicts the orthogonality thesis in philosophy, which states that you can have high intelligence with any set of goals. You could be a super genius who only wants to count grains of sand. If Ilya is wrong, if high intelligence does not automatically lead to high empathy, then we're essentially building a psychopath that can outsmart us at every turn. And that leads us to the final and perhaps most chilling realization. The problem isn't that the AI will hate us. The problem isn't even necessarily that it will be misaligned. The problem is much simpler. The problem is power. In this final clip, I want you to really pay attention because Ilya strips away all the technical jargon and looks at the geopolitical reality.
So if it's hard to imagine, what do? You got to be showing the thing. You got to be showing the thing. And I maintain that I think most people who work on AI also can't imagine it because it's too different from what people see on a day-to-day basis. I do maintain, here's something which I predict will happen. That's a prediction. I maintain that as AI becomes more powerful, then people will change their behaviors. And we will see all kinds of unprecedented things which are not happening right now. And I'll give some examples. I think for better or worse, the frontier companies will play a very important role in what happens, as will the government. And the kind of things that I think we'll see, which you see the beginnings of, companies that are fierce competitors starting to collaborate on AI safety. You may have seen OpenAI and Anthropic doing a first small step, but that did not exist. That's actually something which I predicted in one of my talks about 3 years ago, that such a thing will happen. I also maintain that as AI continues to become more powerful, more visibly powerful, there will also be a desire from governments and the public to do something. And I think that this is a very important force of showing the AI. That's number one. Number two, okay, so then the AI is being built. What needs to be done? So one thing that I maintain that will happen is that right now, people who are working on AI, I maintain that the AI doesn't feel powerful because of its mistakes. I do think that at some point the AI will start to feel powerful, actually. And I think when that happens, we will see a big change in the way all AI companies approach safety. They'll become much more paranoid. I think I say this as a prediction that we will see happen. We'll see if I'm right.
When the power is really big, the rules of the game change instantly. We're already seeing the opening moves of this game. Look at the US export controls on chips to China. That's an act of containment. Look at the rush for sovereign AI in the Middle East and Europe. Every nation realizes that if they miss this boat, they're not just missing a tech trend, they're becoming irrelevant. Ilya predicts that as these systems get stronger, the fierce competition between companies like OpenAI, Anthropic, and Google will vanish. They'll be forced to collaborate, or more likely, they'll be nationalized. Because when the stakes are total control of the future, the free market dissolves. So the scary part is the transition. That moment when the AI is powerful enough to destabilize the world, but not yet smart enough to fix it. That's the window of maximum danger. So essentially, where does that leave us? We're standing on the edge of the transition from the age of scaling, where we just threw money at the problem, to the age of research, where deep fundamental breakthroughs in understanding intelligence are about to happen. We know the current models are flawed. They memorize, they don't feel. But we also know that the blueprint for fixing them lies in our own biology. But remember Ilya's warning, it feels normal right now. The stock prices, the product launches, the hype, it all feels like business as usual. But underneath, the tectonic plates are shifting. My question to you is this. Ilya believes that superintelligence will naturally tend toward empathy for sentient life. Do you buy that, or do you think intelligence and morality are completely separate things? Let me know in the comments below, because this is genuinely going to be the most important debate of our lifetimes, and I want to know where you stand.